Hello, everybody. We're very pleased to have Malcolm Johnson from Durham County Council here, who's going to talk to us a little bit about energy saving, both for ourselves and the council's commitment to those things. So over to you, Malcolm.
Right, good afternoon. I'm an Energy Conservation Advisor at Durham. I've been talking all day, so if anyone's got any questions, I'd much rather go whenever you've got a question. I'm going to cover sort of three areas. One is an overview of what Durham is doing and Durham's emissions. I'm going to touch on one of our projects, which is nearby, which is quite interesting. And I'm going to give sort of my take on some energy saving and some of the things I've done personally at my house. So, in terms of Durham's commitment to climate action, this is not new to Durham. Durham has been working on climate initiatives, for 20 odd years. But really it's accelerated in recent years with a COP event and with our climate emergency response plan. We declared a climate emergency in 2019 that resulted in this climate action plan in 2020. The one that was just released very recently in 2022 is a more detailed plan, and that is really spelling out what we are doing in County Durham. And that covers two things. That covers the DCC buildings that we have direct control of, so the corporate buildings, the leisure centres, the schools that we control, but also what we're trying to do to reduce emissions across County Durham in assets that we don't actually directly control. So there's a lot to read in that, but I think you'd find that interesting. And we're planning out future delivery. So I thought this would be useful to show emissions and targets. You see it's in three colours. The grey section at the bottom is transport, middle is heat, and the top is electricity in blue. So you see we've made big improvements since 2008, but it's mainly been in the electricity side. That's because we've rolled out a lot of solar, and partly because the electricity we buy is lower carbon anyway, because it's coming from the grid, and the grid is decarbonising with time. We've made a little bit of improvement in heat, but I think what really stands out here is you've got that large green section there. Heat, this is heating our facilities, so the county hall, the town halls, particularly the big leisure centres, schools. That's really where I'm spending a lot of my time in focusing on that heat. We have got transport initiatives, but I don't really work in the transport side, so I'm going to cover more of the electricity and the heat elements. We then have county-wide emissions, so this is all the activities around us, and I think that follows a similar pattern in that transport is pretty static. I think that transport actually increased slightly. The heat in green is what we really need to tackle, and the electricity is improving anyway. So, very quick summary, these are the topics that the Climate Emergency Response covers, and it's all activities across Durham, as you can see. But it's the heat, the new development, transport and electricity where sort of my particular focus is. But, this is a plan for the whole of County Durham and all the activities. Please read that when you've got time. The public were consulted on it, but it's a hefty document. But I'm sure you'll find one section that's of particular interest to you. I thought it was probably better that I talk about the projects that I'm more familiar with and where my interest and sort of engineering skills lie. So these are heat projects. So the top picture is part of our low carbon heating depot up in Anfield Plain. It's a transport depot, offices, warehousing, where all sorts of work's being done there to reduce that carbon footprint. So insulation, heat pumps, VRF air conditioning systems that can run as air conditioning or heat to give low carbon heat. It's got a large solar array. It's got a large battery. Really is a showcase, that system. The picture underneath that is a bit closer to home. That's at Woodland Village, which is in Bishop Auckland, so up near Copley. It's a project I manage personally myself, and I've got a few slides on that one that I'll come to in a moment. We're busy across leisure centres, so Abbey Leisure Centre in Frommagate Moor in Durham has had significant decarbonisation. You might have heard about Seaham Garden Village, so it's a new housing development that is to be heated by mine water. We're trying to use some of the benefit that the mines offer us, the shafts where we get quite warm water coming out, and if That water is maybe not hot enough to heat a house directly, but offers a good source of heat that can be lifted with heat pumps to provide heating. One of our focuses really is attracting funding. These measures don't come cheap. PSDS stands there for Public Sector Decarbonisation Scheme, so this is government funding to decarbonise public sector buildings. So we spend a lot of time applying for and trying to secure that money. We have various electricity projects. The picture in the top right is a tan field next to one of our offices and IT centres, provides a significant proportion of the power for that building. We have many, many buildings that have gone across to LED lighting. So light emitting diode lighting offers a huge energy saving over fluorescent lighting. And we're involved a lot with our own solar generation, our assets, roof mounted and ground mounted. So what I thought was a bit closer to home and a bit more of interest was this Woodland project. So Woodland Primary School, 1960s built school, brick built, a school which has always been heated off high fossil fuel. Earlier it was coal, in more recent years it was oil. It's in a village which doesn't have gas, so it was identified as being right for decarbonisation. It had a single oil boiler that was problematic. When the oil boiler wasn't working, the school had to close. It had a few of the features that made it really quite attractive to decarbonisation. In terms of heat loss, it wasn't a bad fabric. It was cavity wall. It had cavity wall insulation. It had quite a lot of new pipe work for heating. So it ticked a lot of the boxes to be able to go for this PSDS funding. It's great that we get PSDS funding, but one of the downsides is we have to build them quite quickly. We have to get the whole work designed, implemented, constructed, commissioned within 12 months. And that's over a heating season when you're trying to heat the place. It's a typical government target where they want money spent by the end of the year and you're trying to do a heating system when you want the heating. Anyway, we applied for that and were successful. What you see at the top there are air source heat pumps. If you're not familiar with these, they look very much like an air conditioning unit, a unit which uses electricity. And the key thing with the heat pump is for every kilowatt hour of electricity used to drive that heat pump, it'll recover at least 2 units of energy from the environment. So 1 kilowatt hour in, 3 kilowatts hour of heat out. In simple terms, it's an air conditioning unit running configured differently. It's an air conditioning unit that will make cold air and push it into the building and it will throw the hot air away. And these air source heat pumps are configured so that they make, well, the cold air is thrown away. So if you go next to these, you feel icy cold air coming out, and the heat is captured into a water circuit and then piped into the building. The heat pumps sit outside where the oil tank used to be, and what you see in the pictures further down is a buffer tank and a hot water tank and the various pipe work, which is basically how the heat pumps store the water and integrate into the existing heating system. That all fits in the boiler house. So heat pumps outside, the rest of the kit, the controls and the pipe work is inside in the boiler house. One important thing a lot of our projects is it's not just about doing one measure, it's about putting in low carbon heating and reducing the heating demand in the building and seeing what else if we can generate some of our own power. So one of the measures was solar power. Obviously solar is pretty commonplace now. One of the downsides of this school is we couldn't use the roof of the school. It's a flat roof. The membrane is not going to last forever. It has asbestos internals within the roof, so there's a lot of concern over using the roof. It has, however, got good grounds. And very early concept, we talked to the school head and teachers and governors about what about a ground-mounted array? We haven't really done a ground-mounted in a school. It's novel. Some people thought it was slightly wacky and we may not get permission for it, but it suited the school well. And with this school it's always been off gas, so it has an electric kitchen. So we have an electrical load that peaks about 11 o'clock. We had an area of land that would face in such slightly southeast, so it would peak its power at about 11 o'clock. So it was actually a really good fit. It wasn't easy getting the consent to do this. We did stumble across some issues with Sports England, and this is one of the barriers that maybe a lot of people might think about. The school has a good-sized playing field, it has a lot of spare land, which is just general open space for children to play. But it all gets wrapped up in this policy from Sports England where it's land that may be used as playing field in future. There's a policy to stop. I mean, really the policy was there to prevent schools selling land for housing, but we got tangled up in that. Anyway, we got through it, and thanks to the school council for writing to Sports England, and thanks to the local councillors for battling. And there you can see the result. And I think what's great about it is it's so easy for the children to relate to renewables because they can see it. They can't touch it, but they can see it. I could talk about this place all day, but I'll try and... So, for me, the key observations are we've put low carbon heating in, but we've reduced energy costs. It's been running for nearly a year, and all the projections are that we're going to save about £3,000. So we've heated it for about £7,000, heated and powered the school for about £7,000, and it would be costing at least $10,000 on current oil prices. So we've seen about 30% reduction. That's because we've got efficient heat pumps, we've produced some of our own power, we've put LED lighting in, we've improved the insulation in a few places. This demonstrates that boilers tend to be oversized. We've approached this on a sort of design basis where we haven't looked at how large the boiler used to be. It's been designed around what's the heat loss of that building, how many kilowatts does it take to heat each room. It demonstrates the ground-mounted solar is acceptable, and we're actually busy looking at another one in the school at the moment off the back of this. It demonstrates we can put LED fittings, we put LED internals into existing fluorescent fittings. And the reason we did that is it's because of asbestos structures in the roof where there's reluctance to touch some of the fittings and disturb it. So it's a way of reducing the energy while minimising risks at the same time. And really it's the engagement with the pupils and increase their awareness of climate change that's the benefit that the school's now starting to see. So in terms of a summary, it's a successful project. We've gone from concept to completion within the 12 months. We've reduced the energy costs, like I've said. We've taken another school off fossil fuel. And of course, we should focus somewhat on the oil facilities, maybe more than the gas, because oil's got a higher carbon emission. Carbon emissions have gone from 22 tonnes to 5 tonnes. And that 5 tonnes will reduce as the grid further decarbonises. And it's now the lowest carbon emitting school in Durham. It's probably the lowest in the northeast, but it's not easy to get data off some of them. Really, if I'd like to thank Bayes and Salix, part of the government funding mechanisms, and for the school for making this all work. So I've touched on one project there. I then thought, really, should I talk about some general energy efficiency that could apply to everybody? That last project really has benefited from some substantial government funding. We can't all get that. So I thought I'd touch on some of my thoughts about and some of my observations from what I've done in my own house. I've taken this from our climate emergency response plan, and I thought it was relevant to show some people to really demonstrate that what this is showing is this is how we're using fuels across County Durham, and what that means in terms of emissions. So what this says on the right-hand side is that 47% of our emissions are because we're trying to heat things. And of that 47, 31% is domestic properties. And I think that's bigger than most public would maybe realise. Yeah, transport is a big section, but the electricity section is significant, but that has reduced. Yeah.
Is that heating buildings or also heating like cooking?
So the 47 in the inner slice is total heating. So the public buildings are within the 3%, the slice towards sort of 12 o'clock on the chart. The commercials 3. How cooking fits into this, good question. It might be in the other, I wouldn't honestly know.
You basically talk about heating buildings.
Yeah. Yeah, I think this data will have come through gas, so I think gas for cooking will be within this data, I think. Can I ask, just to save my voice for a second, is that higher than most people? Is heat a bigger issue than most people maybe thought it was?
I mean, I think what people are realising with the whole energy crisis, isn't it, that suddenly we're all faced with these gas bills, and we suddenly realise that this is a big part of what goes on and a big use of energy, and so I think everyone's getting more aware of it. Probably wouldn't have realised it was that much. Yeah.
Good. So if we think about how we help address that, then that does point us towards insulation, of course. So I thought I'd show what a typical house loses in terms of heat. So I don't know how closely people can read that, but 25% through the roof. Now, if you think back over the last 20 years, there's been various insulation schemes for housing to improve the roof. It's the easy thing to do. It's quite easy to roll out loft insulation. You go through the hatch, you roll the bags and it gets rolled out. There was government schemes for that before. You could say they tackled this the somewhat easy element. 10% out of windows. Well, I think I can generally say a lot of houses, a lot of housing stock and building stock have improved in the last 20 years through double glazing. 15% through drafts and air changes, door openings, etc. Only so much you can do with that. You obviously can improve drafts, but you still need to do air changes in buildings. 35% out of the walls. There has been schemes in the past to retrofit cavity wall insulation. A lot of housing stock built, and commercial buildings since the 90s will have cavity wall insulation. We have buildings such as this that don't have cavity walls, so you can't insulate those cavities. We are starting to see more external insulation now. That picture I showed you a few minutes ago of an office building that looked a bit like a house that had been externally clad. Basically where either battens, like a system where insulation is mounted on the outside, and then it might have render, it might have a fake brick effect, but it's thermally wrapping the building on the outside. That has a huge effect because you're tackling
a property like that, and you do really notice the insulation's brilliant. And it's an old house, over 100 years old, but they've externally clad it. Definitely notice it.
And it's quite quick to do, and it's not too disruptive on the household.
Yeah.
It's you couldn't really do as much internally. It would be costly and very disruptive. But we are starting to see more of that. And then 15% through the floor, which, what do you do about that? So, new build houses, from the 90s onwards, building regulations have been pushed us down the road of putting insulation on the floors before the concrete floors are poured. We have a lot of timber floors, suspended timber floors that aren't insulated, where there's 20 millimetre of chipboard between you and the outside world. That is the really hard element to tackle. I mean, really what we need to see is some more government-backed schemes to drive insulation. You'll see this on the press lately. Is there maybe too much focus on capping energy prices? And really, now you've seen how much heat is going in. If we can get that, the heat demand down, it reduces our energy demand. And it's there for good, isn't it? It's not a machine that you need to maintain. It becomes part of the fabric of the building. I thought I would touch on different ways of raising heat, and it's to help explain the last point about heat pumps. We work with heat pumps, but I appreciate some people don't really understand the sort of basics behind them. So in terms of gas, if you buy a kilowatt hour of gas, because you've got some boiler inefficiency, you might end up with about 0.85 or 0.9 of heat going into your pipes and eventually into radiators. So I know gas prices are all over. I picked a rough price of 8 pence a unit. I might get shot for that, but
gas prices have gone up significantly, haven't they? So.
Yeah. A year ago, some of ours were about 3 pence. I've seen 7s and 8s. I'm really just trying to demonstrate if you were tied into a contract at the moment, it might be about 8. So you're getting heat for about 8.8 pence a kilowatt hour. Now with electric heating, which we tend to call direct heating, so this is electric heating through an element or an oil-filled radiator, that's very simple. That if you put a kilowatt hour into that, you get a kilowatt hour of heat out of it. If electricity, say 30 pence a unit at the moment, heat is going to cost you 30 pence a unit. What we see with oil is tended to follow the gas price. The suppliers kind of link it rightly or wrongly to the gas price. So oil, you'll see, is very similar to gas at the top. The big thing with a heat pump, my last point, is that you put a kilowatt hour of electricity to drive it, and you end up with 3 kilowatt hours of heat. My heat pump at home is currently averaging 3.2. So for every unit of electricity I put into it, I'm getting 3.2 of heat. Depends how the machine's configured. You can see figures near a 4 or even over 4. I tend to talk about air source heat pumps, ground source heat pumps, would tend to be slightly higher figures than that.
There's also a cost in oil and gas in terms of the climate, where those are producing carbon emissions quite significantly, whereas a heat pump presumably is not. Is that a fair comment?
Yeah, it's not producing emissions. I guess it's all about where you're getting your electricity from. in our figures, if we buy power to run heat pumps, we take into account the typical carbon emissions from an average unit of kilowatt per kilowatt hour on the grid. But if we have some on-site generation, that offsets a degree of it. So thinking about the maths, if you put 1 unit in for 30 pence, heat would cost you about 10 pence out of a heat pump. Or if you get the higher efficiency, it's more like 7.5 pence. So at the moment, it's round about the same running costs as gas or oil. It depends on the machine, it depends on the application. But if you can raise some of your own power through solar, or in some systems we run the heat pumps during the night on cheaper power to produce the hot water and keep it in store. Taking those into account, you get heat for about 5 pence a kilowatt hour. So as time goes on, we will eventually see maybe additional taxes on gas and oil to drive us to electrification. So you can see really why heat pumps are to become the norm in future.
So the heat pump, that's really easy to integrate with existing equipment in the house, is it? What sort of process is it?
That's a very good question. So, and I've seen a few of these jobs, so that what was kind of typically the case was the pipe work around the building tends to be fine, but to get the heat pump running at an efficient design point, we normally setting them up for 45 or 50 degrees floor temperature. So in this building, the radiator flow temperatures from the boiler will probably be 70 or 80 degrees C. So that radiator will be designed to give heat to this space with the water coming in at 70 or 80. With a heat pump, you want to be down at 45 or 50. That's where heat pumps are really efficient. So the vast majority of heat pump jobs, we're having to change the radiators for larger surface area units. So the heat pump's putting in water at 45. Because the radiator we're replacing with has got a larger surface area, that's giving the equivalent amount of heat out. The radiator is not as hot to the touch. So within the home or the building, the disruption is normally replacing the radiator with a larger version. And really what the contractors tend to do is to find a radiator, which means that you're not altering the pipe work. So that typically means a single radiator might be a double may become a triple. It might be a little bit taller, a little bit wider, but it fits in the same space. Might protrude into the room by another 20 or 30 millimetres, but insignificant really. In terms of a domestic job, radiators can be changed in a day by a crew, so the internal disruption is pretty minimal. If you have a combi-type boiler where water is not stored, a heat pump requires a small buffer tank, this sort of size, less than a cubic metre, and it requires a hot water tank. So what the buffer tank does, the heat pump produces the hot water and it integrates with the buffer so that when the heat pump goes into a defrost mode, the buffer tank can still heat the house without seeing a dip, and the heat pumps will switch between heating and hot water. When you've got a hot water demand, a valve will switch over and heat a hot water tank. So the normal disruption is putting, certainly in my house, the house used to have a hot water tank. It then got taken out when a combi boiler went in. I've now got a hot water tank back. If you've got an airing cupboard, some go in loft space. So most houses have the space for a hot water tank. There are some cases in high-rise tower blocks where that's become a real problem and they've got a different approach. The other disruption is you end up with a unit outside. Looks like an air conditioning unit, so it's siting that outside. Domestic jobs, probably 2 or 3, 2 days they can fit a heat pump. This is something I bore my colleagues with on a regular basis, which might be of interest. So when I had a gas boiler during lockdown, I was thinking about how much gas I was burning to keep the house warm. And a typical house won't have a zoned heating system, so if I'm heating the downstairs, I'm heating the upstairs at the same time. So I must have been very bored one day, but I started logging how much gas I was using every 15 minutes on the gas meter. I then thought, well, electricity is 3 to 4 times more expensive than gas. But if I put an electric heater in my office, my study office, which is probably about a sixth of the house, and it's the best insulated bit, I found a way of heating my house cheaper, depending on how I was using the house. In 2021, I moved across to an air source heat pump. What I'm finding is the combination of the air source heat pump and the solar, I've got a system that's cheaper to operate. Something else I'm doing, going back on the previous theme of if I'm going to be working from home, at the moment I'd like to buy a battery, but a domestic battery might be £5,000 or £6,000 if you can get one. I'd rather put that into a night storage heater, which you can get basically for free, because they tend to be thrown out. So I'm using surplus solar when I've got some to put in a night storage heater, or I'm buying cheap power during the night to heat the night storage heater, to heat the office. I guess that principle could apply to a lot of buildings where, you know, a large school which, say over the Christmas holidays, might have some staff in, where you only want to heat a very small proportion of the school. It's worth thinking about, is it worth taking a different, even temporary approach to that part of the building, even though electricity is more expensive than gas? That there can be a place for simple electric heating. I thought I would touch a bit on LED lights. I might be teaching you something here that you're already aware of, but you know, we don't see many traditional light bulbs now. I'm looking around this building and I can't see any. We used to have light bulbs that were 60 to 100 watts each. 15, 20 years ago, we went across to fluorescent, sort of compact fluorescent in the house, and strip lights. So the equivalent was sort of 11 to 15 watts. Of course, now we're mainly on LED lights, which are more like 5 to 10 watts, or even less. So if you think of where we've come, we're down at about a tenth of the energy consumption of lighting that we used to be. So LED lighting, really, you shouldn't overanalyze. You should just get on and do it. It's, you know, a lot of the buildings we do as well, we end up with a nicer environment. It's a nicer, brighter, crisper light. It can also lift and almost sort of modernise some of the schools that we do and just give it a nicer appearance internally with LED lighting. One thing that I personally wasn't aware of till last year, and I tried this myself, is if you've got LED strip lights where actually replacing the whole fitting might cost you £30 or £40, plus the labour cost to do it. One thing you can get is you can get LED internals to put into a fluorescent fitting. I bought some for, I think they were £10.50 for a 6-foot one, where probably about double the price of a fluorescent strip. So if you've got a failed strip light, that might cost you £5, you can get an LED for £10. And immediately you're taking a fitting that might be 60 watts down to 21 watts, so you're almost a third of the power in a 10-minute job. I don't think we see enough of that. I thought I would touch on glazing a bit. I've had actually 2 people ask me today on the stand about about glazing. So without getting too technical here, we've got units which is a U value, so it's basically how many watts per square metre per degree Kelvin temperature escapes through that glass. So it doesn't really matter about the units if you just think about the numbers. So single glazing can be somewhere near 6. That's the amount of heat that's escaping through single glazing when you're heating the house. Double glazing that became really prevalent in the last 30 years, typically UPVC, was a massive improvement over that. It was basically half the value, 2.8 to 3. There's a lot of this about. That made quite a difference. I think what surprises people now is how that technology's moved on. The current ones you buy look very similar. You could hardly tell the difference looking at it, but if you look at the specification, through special coatings and a gas-filled cavity between the glass, you get down to sort of 1.3. So half of the heat escape that you had from a window that looked very similar 10, 15 years ago. So some of our buildings where we're doing retrofits, we're not putting in triple glazing, we're putting in very high specification double glazing. And that figure of 1.3 is about where triple glazing was in the first generation of triple. If you go to Scandinavian countries, they've used triple glazing for years. There's now double glazing, which is kind of up there and as good. Of course, triple glazing's moved on too, and that's down at 0.8, but it's expensive. If you're buying double glazing or having an old double glazing repaired, please challenge your suppliers about the specification, because you can see you can get one that's less than half the heat loss, even though it looks very similar. I thought I'd finally bore you with my personal journey of what I've done in my house. I know my wife's sick of hearing about this, but I've been in this house for 17 years, so I've tried to explain this chronologically. So when I moved in, I had incandescent light bulbs, so I went out and got the compact fluorescent. Yeah, big energy reduction in day one. Took 10 minutes to do the whole house. As we sort of modified the house and things started to go wrong, we put double glazing in. And this is a fairly standard specification from 20 years ago. It's a shame it's not the latest, but that is expensive. You've got to think about the embedded carbon in that. It doesn't make a lot of sense to replace that. I've increased the loft insulation. That is easy. I think what surprised me going to the loft of this house that I just bought was how badly laid it was. It was thrown in and there was gaps all over the place. So I took time to flatten it out, fill the gaps in, and I laid the new one at 90 degrees to cover all the gaps. Really took time to get that well insulated. Then 5 years ago, LED bulbs became very cost effective. So the fluorescent lights I put in 12 years or so previous became LEDs. So taking out bulbs that were 11, 15 watt and replacing them with 3 and 5 watt, and actually giving a nicer light. And I went down the route of an air source heat pump, so I no longer use gas in the house. I then had a roof problem on the house, which I hadn't bought a very good house here, have I? It's had lots of problems, this one. My house faces east-west, and you speak to a lot of solar contractors, and they're really historically only putting solar on south-facing roofs. Obviously, I can't pick my house up and turn it around, and I quite like living there, so I started looking at and reading about east-west systems. And actually, east-west, they make a lot of sense. A south-facing roof will give you a peak power at lunchtime. An east-west system will give you sort of a flatter profile over more of the day. Yes, it's a bit more expensive because you're buying more equipment, but that's the house I'm kind of stuck with. If I was building my own house, I'd build one correctly orientated in future. But when you think about a house running a heat pump, east-west with a heat pump is actually a pretty good fit. I've done the LED strip light replacements that I talked about, just to really teach myself how to do it and to try and encourage some colleagues to do it. So these were quite new fluorescent strip fittings. Replacing them might have been £40 or £50 each. For £10 I can put LED internals in them. Actually, it's really quite quick. I then got a solar energy diverter, which is a box of electronics that looks at when your solar is exporting, and then it diverts that to somewhere where you can store that energy. I haven't bought a battery. I think they're too expensive, and I've got concerns about the longevity of batteries. So in my case, I'm diverting that into an immersion heater in the hot water tank, capturing that energy. I can get a price for it when I sell it to the grid, but the price is quite rubbish. Much better to try and capture that myself. So the next bits of what I'm thinking about doing next. My tumble dryer is 17-year-old and it's about to fall to bits. So I started reading about a heat pump tumble dryer, which has a much better efficiency. Obviously, we try not to use tumble drying too much, but there's times in the winter where we have to. It's more expensive to purchase. And it's only really worth doing when the old machine is ready to go, and yeah, now's the time to do that. The one that my wife really hates the idea of is floor insulation. So I might have to send her on holiday to it before I do this, but the worst bit in my house is now I have a large living room, dining room, where between me and the outside world there's 20 millimetre of plywood. That is a big heat loss in that room. It's a big carpet. I don't really want to pull the carpet up and damage that, so at the point that carpet's going, that floor's going to come up. There's now some pretty good systems for insulating under a floor where you jam insulation between the boards, or you drape like a breathable membrane and suspend insulation under the wood. That would make a massive difference. There are some companies trying to promote a system where they send a robot under your floor to spray it, but I think I'd much rather take it up and take the care and get that well lagged. And the next thing is a smarter control on a car charger. So over the summer, I've had some spare solar power. I've been manually trying to adjust the car charge around the solar, but it's a bit like running a power station where you can't keep your eyes off this. Trying to save pennies. There are ways now to automate that. Look at what spare's about and divert that into a battery. I don't really want to buy a house battery because I bought a car battery, so I want to try and get the energy into that. So my house really is a bit of a sort of test bed. So before you fall asleep, I'll best finish off, I think. So hopefully I've covered a bit of what Durham's doing and a few tips on energy efficiency and what I've done. So
thank you then.